This recording will cover the examples shown in the PowerPoint slides for Chapter 4, which is a discussion of multiple regression. So I'm looking at Medicorp 4 data from Chapter 4. And what I have here is a list of 25 sales territories where our dependent variable, sales, is in thousands of dollars in each territory. And then we have several independent variables. The independent variables are all in, the first two independent variables, advertising and bonus, are in hundreds. Market share is in percentages, and then competition is in hundreds as well. So the first thing that I'm going to do is run a regression. And when I do this multiple regression here, I'm going to be discussing a full versus a reduced model. So I'm going to start off doing my reduced model. And in my reduced model, I'm only going to use sales, advertising, and bonus. So my dependent variable sales will be regressed upon advertising and bonus. So I'm going to go into Analyze, Regression, and then Linear. My dependent variable is sales. My independent variables are advertising and bonus. So I'll put those in there. Okay, so what I want to do, I'll go into the statistics area. I would like regression coefficients, I want those estimates. I would like the confidence interval. I would like the model fit. I would like descriptive statistics. Model fit gives me my R squared, so I'm good there. And I will click continue. Then in plots, I would like to have a standard residual plot. So for my X variable, I'm going to select Z predicted. And for my Y variable, I am going to select Z residual. Okay. And click continue there. And that's all the information I'd like to see in the beginning, so I'm going to click OK. And it generates my information for me. So I can see here, remember, sales are in thousands of dollars, so the median sales, or the average sales is 1,269,000. So yeah, we'd have to arrange that a little bit better in order to get something logical. The R squared value tells me the percentage variation in the dependent variable sales, which is explained by my regression. So this regression explains 85.5% of the variation in sales. I'm looking at the R squared. And then the adjusted R squared, that accounts for the artificial inflation of R squared with each additional independent variable. So I haven't yet looked at whether bonus or sales has any impact, whether advertising or bonus has any impact on sales, but I know just by the fact of having two independent variables that my R squared will be artificially inflated. So I look at the adjusted R squared, and that says even after accounting for the additional independent variable, 84.2% of the variation in sales is explained by my regression. So this regression is pretty good. I can look down here at my ANOVA table, which I'm going to need later to do my partial F test. I'll need to look in the sum of squares area there. But for right now, I'm going to go over to my F test and look at my F statistic of 64.83, and then the significance of F, which is 0.0. The F test, the original F test, HO, all of the independent variables together have no impact on sales. So HO beta bonus equals beta advertising equals 0. And I see my p-value there is 0, so I would reject HO. And my conclusion is that at least one of my independent variables does have a statistically significant impact on sales. Then I can go down and look at my coefficients here. and I see that beta 0 is negative 516.44. Beta advertising is 2.743, and beta bonus is 1.856. So since bonus is in hundreds and sales is in thousands, I would say for every $100 increase in bonus, sales are predicted to increase by $1,556, holding everything else constant, or ceteris paribus. In other words, the everything else is holding advertising constant. For advertising, I would interpret that 2.473, I would interpret that beta coefficient by saying for every $100 increase in advertising, sales are expected to increase by $2,473, ceteris paribus. Then I can go on and I can look at the t statistics here for my beta coefficients. I don't care about beta 0, the constant, the intercept, that has no real value for me. But I can look at the significances, the p-values of the other two, and I can test the hypothesis that each of these independent variables individually does not have a statistical significant impact on sales. So HO, beta advertising, equals 0. And in order to test that, I'll look at the significance here of advertising, and that p-value is 0.000. So that I can reject HO. So I'm 95% confident that advertising does have a statistically significant impact on sales. And then similar hypothesis, HO beta bonus equals 0. Significance, or my p-value is 0.017. So again, I'm going to reject HO, and I'm 95% confident that bonus does have a statistically significant impact on sales. And then I can go over to my confidence intervals there. And this gives me the 95% confidence interval impact of that beta. So I would say for each additional $100 in advertising expenditures, I'm 95% confident that sales will increase by between $1,902 and $3,044, ceteris paribus. And then similarly, for every $100 increase in bonus, I'm 95% confident that sales will increase by between $372 and $3,341. Now I can go down here to my scatter plot and analyze that scatter plot a little bit. These are the standardized residuals. And when I'm looking at this scatter plot, what I'm hoping to see is no apparent pattern in my standardized residuals. So when I examine this, I don't really tend to see much of a pattern. These are the ones that are standardized, and remember, we standardize them because they face different variances, and we want to bring them all. This is like, calculating the equivalent z-score value for each of these, and I do not see a pattern, which tells me that assumption 1 is probably not violated, and that I'm probably good following my general assumptions with OLS. We will go into analyzing these assumptions in Chapter 6 to ensure that we are, in fact, following all of them. Okay, so additional hypotheses that can be conducted. Let's say I wanted to know, does bonus have a positive impact on sales? So does bonus have a positive impact on sales? Having a positive impact would mean HO, we're looking at beta bonus being less than or equal to 0. So because HO is always the opposite of what you expect. So if I think it has a positive impact and T is positive, all I have to do is take that p-value and divide by 2. Does bonus have a positive impact? And is T positive? Okay, t is positive, so all I have to do to test HO beta 0, or beta bonus is less than or equal to 0 is take that significance value, that 0.017, and divide by 2. So that's 0.0085, which would say, yes, that's obviously less than 0.05. I knew that even before dividing because it already, the two-tailed one already was less than 0.05. So I would reject HO, and I would conclude that bonus does have a statistically significant impact on sales. Just glancing over at other tests here that are discussed. Okay, to do the model comparison, to do the full and reduced model comparison, what I would need to do now is look at the sum of squared errors. Now, what's a little bit different, so I'm going to go back into my ANOVA table. In order to conduct my partial F test, I need to look at SSE. The SSE for my reduced model, this is the one that only has these two values in here, bonus and advertising. That's this 181,176.419. That is actually my sum of squared errors. Even though it says sum of squared residual, remember residual means error. So that's the SSE I will use to do my analysis. I'm not going to show you the actual calculation in SPSS. You might as well just do that in Excel because it's just an application of the formula. So I think it's actually easier when you have a regular spreadsheet system and you can do those individual calculations. But I will show you the other calculation to get the full model. So I'll go back to my data and I will go into Analyze, Regression, Linear, and now I will make sure to add in these two additional components. Keep everything as I had before, and I'll check OK. So now to do that partial F test to compare the full and reduced, I'll compare that 18,000 number that I had before with this 175,855.198. So that's the SSE that I'll be using for my full model in order to make that comparison. The next thing I want to show you is actually calculating the variance inflation factors in order to check for multicollinearity. So this is a little bit different. I talk about the idea when you're doing this in Excel too. What you need to do, so we'll go back to our data. What you need to do is regress one independent variable on the other independent variables. Now here, there are only two, so I'm going to go into Analyze and Regression Linear. I'm going to click on here. I'm going to take out sales. When I conduct my partial F test, I will learn that the value is not significant and market share and competition do not add significantly to the model. So kind of gave that away. So there's no reason to include them. So I'm not going to look at them there. But so I'll just do this variance inflation factor calculation just using advertising and bonus. And if I take out advertising and make it my dependent variable. So to calculate the VIF, what you need to do is regress one independent variable on the other independent variables. Well, here there's only two independent variables, so I only actually have to do this once. Now I'm going to go into statistics here, and I don't really need my descriptives. My model fit is fine. I do need collinearity diagnostics to be involved in there. I'll continue that, and then I don't want any plots, so I'm just going to take both of these out and click continue. I don't need to have any plots that are going to be shown to me there, and I'm going to click OK, and then I'm going to scroll down, and I see this, go over to the collinearity statistics. So I'm looking at this model down here, which is regressing bonus on advertising. So my dependent variable is now advertising, my independent variable is bonus, and my VIF here is 1. So that doesn't really indicate a problem. I would definitely have a problem if any individual VIF, like this is an individual one that I just calculated between advertising and bonus, if any one of those is greater than 10. In general, some people will say if it's greater than anywhere between 3 and 5, it probably indicates a problem. There's also a problem if the average VIF is greater than 1. So this one is 1, or considerably larger than 1. This one is 1. A VIF in general of 1 really isn't much of a problem. So I would conclude that I really don't face too much of a multicollinearity issue here, and I should be fine. So that is the example that we show in the PowerPoint slides for Chapter 4.